welcome once again. Kindly subscribe to this channel as you continue watching. You can also share the link. Form 1 topic are called measurements, whereby I will concentrate with the measurement of volume. So volume from regular solids can be measured or determined using specific formulas. For example, if it's a cylinder, everybody knows a cylinder is of this shape. Therefore, you find to get the volume of a cylinder, we use a formula. Volume is given by pi r squared, which is the area of the cross-section area, 10 times the height of this, the height of the solid called cylinder. Therefore, if a solid is regular, for example, cylinder, the cuboids, the cubes, the pyramids, and all that, they have specific formulas which can be used to determine their volume. So what I want us to focus on is measurement of volume of irregular solids. So for irregular solids, if a solid is irregular, how do we determine its volume? Therefore, we use the displacement method. The displacement method, whereby we use an instrument called the Eureka can. The Eureka can is also called the overflow can. The overflow can. So when we are using the overflow can, which is just an instrument which is made such that it has a spout. A spout is this outlet which allows excess water to flow out. Therefore, what we do when we are using iron, we just fill what I need. We fill what I need until it stops flowing out of the spout. It's called the spout. So we first of all fill the Eureka can with water. Until it flows out through the spout. Then when it immediately stops flowing out, when it just stops flowing out, we can now tie the irregular solid. The irregular solid using a thread and we lower it gently into the Eureka can. As you place a measuring cylinder below the spout. The measuring cylinder below the spout. Therefore, you find we place a measuring cylinder here. A measuring cylinder is a graduated instrument used to measure volumes. Therefore, it is graduated in millimeters or cubic centimeters, such that now, when we dip in the irregular solid here, which has been tied, because water had just stopped flowing out, it now starts flowing out due to the immersion of this solid. This is the irregular solid. So once it immediately stops flowing out, now we can now determine the amount of water which overflows. So the volume of the water which overflows is equal to the volume of the solid. The volume of the solid. Therefore, we are having an irregular solid here whose volume cannot be determined using the formulas. For example, the one we use for cylinders. Therefore, because you cannot use the formulas, we use a eureka can. This is called a eureka can. These apparatus here. Therefore, we put water in it first of all until it just stops flowing out. Then, when it just stops flowing out, you should be sure that produce an additional volume into it. Then water will flow out, as long as the solid is not miscible with water or does not react with water. Therefore, this solid, once immersed in the liquid, which is water, of course, it's a common liquid we use in the lab. So when we immerse the solid, which is irregular, water starts flowing out, and the water which flows out can be collected now in a measuring cylinder. This is the displaced water. The displaced water. That's why we call it displacement method. Therefore, the water which gets displaced, its volume, because can now be read from a measuring cylinder, we equate it to the volume of the irregular solid. Or we argue that the volume of the irregular solid is equal to the volume of the water it displaces. Therefore, the volume collected here is equal to the volume of the irregular solid which has been immersed. Therefore, that is how we get volume of irregular shapes using the overflow can. Thank you for following. Kindly subscribe to this channel and share the link with your friends.